So my name is David Grover. I'm a senior civil engineering student here at the University of Vermont. My advisor is Donna Rizzo, and I'm doing a Barrett summer research scholarship with her, looking at trying to predict the depth to groundwater using artificial neural networks. I got involved with this because I'm very interested in programming and artificial intelligence, things of that sort, and I wanted to do a summer research project, and Donna suggested I get involved in the Barrett. So it's been a great experience so far. I've learned a lot about research and all the different hang-ups you can get involved with in research as well. My project basically is looking at different geographic elements such as precipitation, elevation, slope, rivers, the distance from a certain well to a river, trying to use all those geographic features to predict the depth to groundwater. And it's a fairly difficult exercise because the things we're using to predict on don't have a lot to do with groundwater. They're not the main drivers in what makes the depth of groundwater. So we're having a hard time predicting it. But it's been a very fun project trying to find workarounds and trying to find pieces of data that we can substitute for the more reliable groundwater predictors. Depth to groundwater is a very difficult problem that is chronically plagued environmental engineers, from what I've heard. So I'm just trying to add one more piece of research to that. And I see why they're having such a hard time predicting depth to groundwater. They do. They have a very effective way. They drill a well. It costs tens of thousands of dollars. And they drill another well next to it, and another well next to that, and they look at how far down they have to go to hit groundwater. Very reliable, very, very costly, and if your goal is to try to assess a site cheaply, it's not your best option. What is your best option? It's just no one likes to do it. Not that I'm aware of, but I think I'm going to start trying to head in that direction. Again, the goal for us is to be able to look at a map almost and take data off of that map and predict. The ideal would not even have to go out to the field, but the second best would be to get some kind of ground penetrating radar or something, or sonar, something of that sort, and use that to find groundwater. But soil is a lot different from the ocean. Water is fairly consistent. You can just send a depth charge down. As soon as it stops hitting water, you know it's hitting the bottom ocean floor, so you've got it. While when you're trying to go through soil, and there's all these different layers of soil, you might hit a layer of clay, which is not actually groundwater. You might hit rock, you might hit bedrock. Who knows how that'll affect the signal bouncing back to you.